All right, welcome. Today we are talking about trigonometry. This is basically another extension of what we've been talking about the last couple of classes with our similar triangles. So in the last lesson we talked about how triangles that have a specific set of angles, right, the 30, 60, and 90 degree angles, will always follow the same proportions. Well, today what we're going to do is take that and extend it to not only does this work for 30, 60, and 90 degree triangles and 45, 45 triangles, but it will work basically for any right triangle. So the thing that we need to know are that there are basically three ratios that apply to the proportionality of any right triangle based on the angles in that triangle. And those three ratios are sine, cosine, and tangent. You'll notice these buttons, you see them on your calculator, but you probably haven't really used them a whole lot until now. Basically, each of those is an operation or a function that is basically telling you the proportion of two sides based on a given angle that we will call the reference angle. So that reference angle will have to be one of the angles in the triangle. It will also not be the right angle, so this is going to be one of the two acute angles. To remember how these ratios work, we will need to know a little phrase. That phrase is pronounced Sohcahtoa. So what do these letters stand for? Well, if we know what the letters stand for, the acronym will make sense. That's what we have in this table here. So the sine of the angle is equal to the opposite leg over the hypotenuse. The cosine of the angle is equal to the adjacent leg over the hypotenuse. And then the tangent of the given angle is equal to the opposite leg over the adjacent leg. So if you look at that, right, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So how do we see this in action? How do we use this? Well, what they're going to do is give us an angle. So in this example, we're looking for the sine, cosine, and tangent of angle P. So we're going to use P as our reference angle. So what I'm going to do is find angle P. And then from there, I'm going to label my opposite leg, adjacent leg, and hypotenuse. Well, hypotenuse is the easiest one to find, right? Because it's always in the same spot. It's the one that does not touch the right angle. From there, the adjacent leg, if we remember from before adjacent angles, right? It's always something that's next to whatever you're looking for. So the adjacent leg is the leg that is closest to the angle that was given. And then the opposite leg is the one that is farthest from your reference angle. And then from here, we're just going to use our little acronym to find the three ratios. So if I want to find the sine of angle P, I need to take the opposite leg and divide by the hypotenuse. So in this particular triangle, it would be 15 over 17. If I want the cosine of angle P, I'm going to take the adjacent leg and divide by the hypotenuse. And then finally, if I want the tangent of P, I'm going to take the opposite leg and divide by the adjacent leg. So that's pretty much it for finding our trig ratios. So in the next few examples, what we're going to see is how we use this to solve for missing values in triangles. So in example 2, first thing is we want to find the tangent of 30 degrees. And I'm just going to give it as a fraction. We can type that fraction in our calculator to get a decimal. You can do that on your own. But if we remember from last time, we said that any right triangle with a 30-degree angle and a 60 has to have a 60-degree angle. And it always follows the proportions of 1, 2, and square root 3. So if I would like the tangent of 30 degrees, I'm going to write out my Sohcahtoa so I can remember which ratios go with which sides. So if I want the tangent of 30 degrees, I'm going to use the 30 as my reference angle, so it's over here. And then I need to once again identify my parts. So my hypotenuse is here, my adjacent leg is next to the 30-degree angle, and then my opposite leg is across, or as far from the angle as possible. So setting up my ratio, tangent is opposite over adjacent, so it's 1 over the square root of 3. And then like we saw in some previous lessons, I can rationalize that denominator to get root 3 over 3. Alright, so the next thing we need to realize is that if I am given an angle, I can use sine, cosine, and tangent to find the ratio of the sides. Conversely, if I am given two sides, if I'm given the ratio of the sides, I can use that to solve for the angle. And so on your calculator, you have buttons for the inverse of sine, cosine, and tangent. So the thing that you're going to have to remember when you're working these problems is whether you want inverse or whether you just want to hit the button as is. So if I'm given this problem and I want to find the measure of angle A to the nearest tenth, I'm going to find angle A. I'm going to identify my parts. So here's my hypotenuse. Here's my adjacent side. And here's my opposite side. So if I want to find the A, and I am remembering my Sohcahtoa ratios, my acronym, I need to figure out which trig ratio I can use to find A. So if I look at what's filled in, I have my opposite leg and my hypotenuse filled in. Sine uses both the opposite leg and the hypotenuse. So I'm going to say the sine of A is equal to 8 over 27. And if I am solving for A, I'm going to get my calculator out, and instead of typing sine A because I don't know what A is, I'm going to type inverse sine of 8 over 27. And if my calculator is in degree mode, when I type this in, it should give me the correct answer. So doing that, it said measure to the nearest tenth, so I can round off. I should get that A equals 17.2 degrees. And our final example for the day, we're going to take a triangle and solve for the missing pieces using what we've learned the last couple of lessons. So it says solve the triangle, which means find the missing parts, and we're going to round side measures to the nearest tenth and angles to the nearest degree. So if we look at what we've got, we know that if we know the two legs, we can use our Pythagorean theorem to get the hypotenuse. So 5 squared plus 9 squared equals c squared. Right, type all that in. So c equals the root of 106. And the problem specifically said to round to the nearest tenth. So that's going to give me a 10.3. Okay, so I need to find at least one angle. It doesn't matter which one I find first. So I'm going to find x first. I'm going to remember my trig ratios. So once again, Sohcahtoa. I'm going to label my parts. And since I was given the 9 and the 5, I'm going to use the ratio that uses the opposite and adjacent legs, just in case we messed up the calculation on the hypotenuse, even though we're pretty sure that we got that right. So we can say that the tangent of angle x is the opposite leg, so 9 over the adjacent leg, which is 5. So when we type it in our calculator, again, if we want an angle, we use the inverse button. So x equals the inverse tan of 9 over 5. So x is about 61 degrees. And then to find angle y, right, we just have to remember that all the angles of the triangle should add up to 180 degrees. So if I take 180, subtract out 90, and then subtract out the 61 that I had, should give me about 29 degrees. There we go. And so now we have solved the triangle because all of the missing angles and sides have been filled in. That's all we have for today. I will see you next time.